Hello everyone. Today we will be talking about reinforcement learning, which is one of the machine learning techniques to train AIs to play games. And in our examples, we're going to use uh, the stable-baseline 3 frameworks, which is one of the best reinforcement learning frameworks, in my opinion, that can be used to teach AIs. The game that we are going to train the AI to play is going to be the snake game. And for that, we are going to use Python during this video. So before we start teaching the AI to play that snake game, let's go ahead and play that snake game by ourselves. And for that, I will start by creating a new project and I will use pycharm as my IDE. And while the PyCharm IDE is being initialized, the snake game that I'm going to play is from a GitHub repository that I'm going to share in the description by someone called Rajat Biswas. So I will create a new project. I will call this snake-AI-project. And it's using Pygame, which is a library that is used to create games using Python. And this will take some time until the virtual environment is being created. So I will go ahead and just talk a little bit about stable-baselines 3 framework and what reinforcement learning is. Reinforcement learning is used based is based on giving actions to the AI. So let's say in our AI example, our actions would be like going up, down, right, or left. And you want to reward or punish that AI based on the action that it makes. So if it did a good action, you reward it. If it did a bad action, you punish that AI. And I will continue about talking about this, but let me go ahead and install some dependencies that we are going to use in advance. So we will need pygame, and we will need gem, which is where we are going to create our environment, and we will see what that means in a second, or I mean throughout the video. Yeah, and as I was saying, the AI picks some action, and if it picked the right action, you reward it. If it picked the wrong action, you punish it. And then the AI keeps iterating through each step, and then it basically will try to make the action that will return the best reward. That's how reinforcement learning is being done. And there are a lot of great examples on how AI was used. And very good examples you can see are from OpenAI, DeepMind, etc. And two favorite examples that I am aware of is AlphaZero, which is an AI that have even beaten, or if not even crushed, Stockfish, which is the best chess game engine. And another example that I can think of is Dota 2, and I've been playing that game for over 10 years. It's a very complicated game, and they even have beaten the world champions, which is something way too astonishing at that time. Yeah. And that being said, I'm still installing some dependencies. I've installed so far Pygame, I've which is the library that we are going to use to play our games. then gem, which is going to be used to create our environment, and the stable baselines 3, which is our framework to uh, imply the reinforcement learning. And after that, I will install another library called pyglit, which is a library that is being used by many of the built-in gem environments uh, in order to render some of their examples. And the reason why I want to do that is because before we start and train our AI to play the snake game, I want to show you a sample example and then build over that example so that you understand what each line does and how to do it and what it actually means. So we will start by playing the snake game, understanding its rules, seeing how it's being played. Then step number 2, I will show you a sample example that they have for stable baselines 3. And then the last step, which is the step that we are waiting for, is to create our own snake environment, our own custom environment in Gem, and then teach the AI using that environment to play Snake on its own. And this is the last dependency that I want to install. And of course, without I even mention this, you don't have to use pycharm as an IDE. You can install these dependencies using pipe install, but I'm using the IDE and I'm using a virtual environment for that perspective. Okay, so it has installed all the dependencies that we need for this video. I will create a new file that will play the snake game. I will copy this and just paste it as is, and let's play the game. Now you'll see I don't have an option to run the game. It's because there are some background tasks that are happening in PyCharm. It shouldn't take a few seconds, I hope. Okay, now I can run the game. And here there's something very important that I want to mention. So let's start about the moves or about the actions that we can make. We can either go to the top, to the right, to the bottom, and to the left. As you can see, there are, in order to like get a better score in the game, you reach the food, and as you can see on the top left, the score keeps increasing. And there are two ways to lose the game, or two conditions. One condition is to eat yourself. So I will try to eat myself, and I died. And as I can see, this you died screen. And the second condition is, which is not no usually available for many snake games, which is that if you hit the wall, you die. You'll see in most of the snake games, when you hit the wall, you run, you go from the other side. And one last thing that I want to mention, which is that you cannot return 180 degrees. So if you were already going right, you cannot go to the left. And if you were already going to the top, you cannot go to the bottom immediately. You have to rotate like to the right, for example, and then go to the bottom. So this is basically the basic rules of the game. How do you win the game? Basically, there's no realistic way to win the game, but you want to achieve the highest score by eating food, and you lose the game in two conditions: by touching yourself or by hitting one of the four walls on the edges. Let's go to the main.py and let's go to the step number 2, which is to use a sample example that they have, and we are going to explain what each line does. Let's go. Okay, first I'm importing gem at line number 1. Gem is used to create environments. And inside these environments, environment is a class, is a Python class, and it has list of functionalities, which we will go into a lot of details. For example, it has a step function. So for each action you make, you go to the step function. There's a reset function which resets all your variables. Then you have the render function which will render your results or your model prediction on the screen. So in our snake example, rendering means the window, the snake, and the food, and we can see how that's being interacted on the Pygame window. And we have a close function which will close your environment. So in our Pygame example, that would be quitting the game. And it has a constructor, and inside that constructor you can add all your initialization logic, just such as putting the snake position, the initial snake position, setting the game window, setting the initial food position, and so on. Line number 3, this is we are importing our reinforcement learning algorithm. And I recommend that you go to the documentation and go here and go through some of the algorithms that you can use for stable-baselines 3. There's actor critic, there's DDPQ, DQN, PPO, etc. And my advice is when you train your model, try to train it using different algorithms and see which algorithm will give you the best performance. Line number 5. This is where we are assigning the environment, the gem environment to a variable. Gem has many pre-built environments, and I recommend that you actually go to the gem GitHub repository and look at the code for many of these environments. In this example, we're using the cartpole environment. The cartpole is you have a cart, which we will see, and you have a pole on that cart, and the car's job is to balance the pole to, to prevent it from falling down. So if the pole was below a certain angle, you lose the game. You lose this game. Line number 7 is where you initialize your model. So you provide your reinforcement learning algorithm, and some of them have different policies, which you can read in the documentation. Some of them don't even have this policy. And then after that, you train your model and you provide how many iterations you want it to train. So the bigger the number of iterations, the better, but at the same time, it will be more time consuming. Line number 10, this is where you sit in the environment, because when you train your model, after the training is done, some of the variables would not be initialized to their initial state. So you want to make sure that you do that before you test your model and see how it works in action. Here we are iterating for 1000 step. Step is what is action. Like basically step is an action. So for each action you move one step in your environment, and make sure that pay attention to what I am saying. Right now you don't know what a step is, what is rendering is. You will see all that in much details. So at line number 12, we are taking the action from our model, and then we are passing it, and then we are rendering and see the results on which action did our model make and how it looks like in our render function, or how it looks like in the window where we are seeing our logic in action. That's basically it. Once we are done, and this is very important, when the game is over or when the game is done, we want to make sure that we reset everything to its initial state so that we keep playing again and again and again. So that's the purpose of this if statement. That being said, I will go ahead and run this example. So if our model was trained correctly, then the pole should stay balanced on that cart. Now, 10,000 iterations usually takes around maybe 30 seconds, so it shouldn't take that long. But if you are training for 100,000 or for millions, it's very normal that training takes for days, or if not weeks. So as you can see, our model is doing a very good job in balancing that pool by trying to move right and left to make sure that the pool stays balanced. So this is a good indication that we have trained our model correctly. Now, of course, it was trained correctly because this is a pre-built environment and the logic behind it was written correctly. And there are like over 10 examples that you can see in Gem beside this one. And believe it or not, many of these examples are very complicated that even my snake environment that I will show you is easier than many of them. So now we saw what how this works. We saw what the game is about. Let's implement the logic to train our AI to play the snake game. So the first step to achieve that is to create our own gem environment instead of using the pre-built environment that we see in line number 5. How can we achieve that? Let's go to the documentation and let's go to the using custom environments section. I will just copy this copy paste, and then we will explore what that custom environment looks like. I will put it uh, in the same files so that we can navigate much easier. I will start by going to line number 10, which is the metadata. We can generate information about this environment. The metadata that's provided here is render modes. And there are many modes, but I want to introduce you to two of them. Something known as human and something known as console. Human is usually used when you are rendering something to a window. So in the cartpole example, it actually used the pyglit library. In our snake game, we are using the pygame window. So when we are rendering our function, we can see the window, we can see like the pool, we can see the cart, we can see things visibly on some sort of a window. That is used mostly for the human mode. For the console mode, this is used when you are not rendering something on a window. Instead, you are printing statements or printing things to the console. This is where the word console came from. But since we are using Pygame, we are going to keep this as human. And this is the constructor for the environment. Now we can pass arguments just like any Python like class. However, we are not passing anything in our case, so we will keep the self keyword, which is similar to the this keyword in Java and JavaScript. I will call this the snake environment just to be consistent with our game. And the most important, there are three very important lines here, which we will keep. This will call the super constructor, which is for the gem.env class. There is something known as an action space, and there is something known as observation space. What do they mean? Well, let's start with the action space. Action is what action are we making, right? So for each step that the AI is making, what are the action? What are the steps? What are the um, inputs that it can do? So the cartpool example, there were only two inputs. You can either move the cart to the right or you can move the cart to the left. But for the snake example, we have four. We have we can either go to the right, to the left, to the top, or to the bottom. And there are two types of action spaces. There's something known as discrete action. There's something known as continuous action. Discrete action is when you have only one discrete or single value of action that you would make for each step. So in our snake game example, it's only up, only bottom, only right, only left. You're not making multiple stuff for each step. You're only um, clicking or hitting just one keyboard for each step, and therefore our action is going to be discrete. And inside this spaces.discrete function, we are providing what is the maximum number of inputs that we can have for our model. So in our case, this is going to be 4. And to illustrate that, I will put that in a variable and just pass it here so that when I push this to GitHub, you can have a better understanding of what we are doing. The line number 20 is for the observation space. What are the things that we are observing in our environment that are affecting our action or our AI? So, now let's think about this logically. How should we determine if we should move right or to the left or to the top or to the bottom? Well, we need to know where our snake is and we need to know where our food is. Or in another word, we need to look at the position of the snake and the position of the food. And since this is a 2D game, each position has an X value and has a Y value. So we have the snake position in X, we have the snake position in Y, we have the food position in X, and we have the food position in Y. Therefore, we have a total of 4 number of observations that we are making. So let's go ahead and write that down. Number of observations equals 4. And now you can set limits for the observation. What is like the minimum value? What is the maximum value? Many of the gem pre-built examples, what I've seen is that they set this to minus infinity to positive infinity. And for the shape, we provide the number of observations, and we can ignore these two. This is if you want something um, that is more complicated. But in our sample case, what I recommend is just set that from minus infinity to plus infinity and set this to float and just pass the number of the things that you are observing. And what else? Well, we need to import the NumPy library. So let's go ahead and do that. Okay. I'll just try to put this on the same line so that we can read this much easier. So that is for the initialize function constructor. Now we are going to add more stuff, so stay tuned. In our step function, this is the function that gets called for each action that is made by the AI. So which is right or left or top or to the bottom. So for example, when we are moving our snake, the snake position changes. And like for example, if it ate some food, that food disappears and moves to a new direction. We will see how that looks in a second. We will see that it returns 4 values: observation, reward, done, and info. Observation, as I mentioned, the observation space are the things that we are observing. So in our case, that would be the snake position in X, snake position in Y, food position in X, and food position in Y as a NumPy array. The reward is the most important thing that I want you to focus on. So it's a numeric value between like minus infinity to plus infinity. If our AI did something good, we want to reward it with a positive value. And if our AI made the wrong action, then we want to reward the AI with a negative value. And the bigger the magnitude of that reward is, the higher the impact. So a plus 10 is better than plus 1. And a minus 10 is much worse than minus 1. Done indicates when the game is actually done. So in the cartpole example, that would be when the pole falls down or goes below a certain angle. For the snake example, it would be either by either by the snake eating itself or by hitting one of the 4 edges or walls. The info is an optional object that you can return by your step function. In our example, we will make this as an empty object. However, you can, here, if you want like to look into some variables or you are concerned by some stuff, just put them in the info, just put them in the info object here. The reset function is the function that is responsible for resetting everything to its initialized state. So for example, in our snake example game, we want to initialize the score to 0. We want to initialize the snake position to where it was, which is usually at the top left. We want to initialize the foot position to some random position, and so on. And we return the observation, and the observation is for the reset system, or the reset function is the same as the observation of the step function. The render function is where you put all your rendering logic. So for example, displaying the window, um, changing the score, all that stuff is probably inside the render function. The close function is how you would close your game. So in our example, since we are using pygame, the function is pygame.quit. So let's fill out these functions based on the game that we already have here. First, I will start with the difficulty. So this difficulty is used for the frame per second controller. So the higher this number is, the faster the snake or the game goes. So I will copy that. And for any constant values, I will put them exactly under the class. But you will feel free to use Python in any way you think fits you the best. And for the difficulty, I will pick 20 because I'm trying to make the game a little bit easier to explain to you how to train the AI. Now, of course, the bigger the difficulty is, the bigger for example, the bigger the window size is, the harder the game is. But in return, you can do like more iterations, and your AI performance will be better. But I don't want to take like hours training the model on this video. And so for that same reason, I will divide the window size by 2. So that being said, let's scroll down. This is where we are initializing our pygame. It is being assigned to check errors. So if there's an error, it will print it. But I know for a fact that you should not expect any sort of errors. So I will initialize this. And as we mentioned, any initialization logic should be inside the constructor of your gem environment. So I will put that here, and I will import pygame. Let's continue. Again, these are stuff that happened when the game is initialized. He even wrote the comment about that, so let's put that here. And now I want to explain something very important, especially for people who are not aware of Python. You want to make sure that for your object variables to prepend them with a self keyword so that they can be accessed in other functions. Like for example, this game window variable will be used in other functions, as you can see. So for that, I will prepend this with the self keyword to make it an object variable. And this is something that you will see me do a lot through the video. And these are the colors, they are constants. So I will just put them at the top. This is something that only happened at initialization. And the truth is, anything before the while loop is something that happens on the initialization. Because the reason why we have a while loop in the Pygame is because we want to keep iterating, because there are stuff that keeps changing while the game is being played. So let's copy all these lines together. And let's put that here. And again, this is something that you'll see me do a lot, which is to prepend our variables using the self keywords. Now you might be wondering why I'm not prepending the random, because this is not a variable. This is the library that we have from Python. And now all the errors that we have are gone. And now we have this game over function. If you remember when I died, we saw the red, you died in red on the screen, and we saw the score at the bottom in red. Now, when we test our model, we don't want to see that every time the model loses. Instead, we want to do something similar to the cartpole, which is when the game is done, we want to reset everything to its initialized state, and then we want the game to play automatically, so that we don't keep wasting time. So for that, I'm going to make this game over a variable, or to be more precise, a Boolean variable. So we will not do all this logic, so that the game keeps being played even after we lose. So for that, I will create this variable, and I will assign it to false. My bad, because at the beginning, it's not game over, obviously. And this is the show score function. This will show the score on the top left. I will put this function at the bottom. And since this is a function inside the class, I have to assign the self at the beginning. And as usual, we assign this to all of the variables, as you can see here. Okay, everything looks good so far. Let's go down. And now this is the main logic, as you can see here. And then all our logic that is not related to rendering, but the logic of your game itself, should be inside the step function. Here, as you can see, if we are trying to quit the game gets quitted. So let's put this inside our close function. And here, let's import the assess package. And let's go back. And here, when I was playing the game, I was using the keyboard. And there are two ways to play the game. Either use the up, down, right, and left keys, or you can use WASD, just as in most games. Now, in our case, the input is the action itself that is being passed to the step function, as we can see here. But before I tell you what that value is, let's copy this logic for now and see how it looks like in action. And now, just before I continue, I will make sure that this return function is on the same indentation. So we said this is the input, right? This is what the AI provides as an action. So what is the value of that action? The value of that action, since we are using discrete space, as we've shown in line number 50, it's actually going to be a constant. And that constant depends on the number of actions that we have. And since the number of actions is 4, that means that the action value ranges from 0 to number of actions minus 1. So in our case, since number of actions equals 4, that means that the action value is from 0 to 3 inclusive. Now we can deal with numbers in our code, and that will be totally fine. But if we want to make the code more readable, it's highly recommended that you replace the numeric values with constants. So for that, I will create a constant for each action that our environment or our model can make. So I will call this action constants. And just before I continue, I just noticed this FPS controller. It should be after the game is after the Py game is initialized, if I'm not mistaken. Let me scroll up. Yeah, it had to be after you initialize the Py game. Okay, let me go back to the action constants. So I will create 4 constants: left, right, up, and down. And I call them this way to be consistent with the snake game file, as we will see in a second. Up equals 2 and down equals 3. So now we want to say if action is up, this is up. If action is down, this is down. If this action is left, this is left. If action is right, this is right. So we are replacing the keyboard events with the action value. So let's do this. And in the second case, oh, sorry, this is up. This is down. This is left. And this is right. And again, all these variables, make sure that they are always dependent by the self keyword since they are objects. Now let's continue. There is a small event which is if we hit escape, we are not going to hit escape, obviously. I will copy these two at the same time just to save you some time. And I will take this and I'll put that here and just make it this things easier. Let me do this. And I will explain to you what this logic does in a second. Sorry, this is the snake position. Okay, so for this code, remember when I told you that the snake cannot return 180 degrees? So if the snake went to the is if the snake was already hit looking at the right, you cannot go to the left, and the opposite is true for all the positions. This is the logic that enforces that. And now this is the logic that changes the snake position when you are moving to a certain direction. So if you're heading to the top, obviously the snake position changes. The same goes for all the directions. Yeah, let's continue. And as I did previously, I will just append all of these with the self keyword, and then we will explain briefly what this logic does. Okay, so what does this logic do? So every time the snake moves, its body size increases. But then why the snake body size stays the same when you don't eat food? Because if you don't eat food, the snake body decreases by this pop function. But if you ate the food, the snake body increases and it doesn't decrease, and that's how the snake body keeps only increases when you eat food. And obviously, if you eat food, or if the position of the food is the same position as the snake, you increase your score, and then you set the food spawn to false because you want the food to disappear and then appear in a completely different position. And that is the logic here. So if the food spawn is false, or if you ate the food in another language, make sure that you put the food position in a different place and make sure that the food is being spawned. Let's scroll down. GFX stuff, game window, pygame draw rectangle, pygame draw rectangle. All of these are what? All of these are related to rendering the page, not related to the logic itself. So what does that mean? That means we need to put them in the render function. And I don't have to explain to you, this is the function that's responsible for growing the snake food, etc. And the snake body. Yeah. This is the conditions of when the game is over. So when is the game over? We have two conditions. One is if we hit one of the edges or one of the walls, and the second condition is when the snake eats itself. So this is for the wall, and this is when it touches itself. Yeah. And here as I mentioned, I set this to a Boolean value of false and true. So in this case, this would be a value of true. And let me do the same thing here and in here. Okay, everything looks good so far. Let's scroll down. Showing this code, updating the display, and changing the frame per second controller. All of these are related to rendering. So let's take this and let's put this in the rendering logic. Okay, I apologize. I just noticed something weird. This should not have the self keyword, and that's why it was complaining. The pygame is initialized once, and that's it. You don't need to. You should not prepend this with a self keyword. Okay, and that's it. This is you've done your one of the most important steps, which is to take the logic of your game and split it into the functions that you have. Okay, so now we are done with the close function completely. We are done with the render function completely. The only two functions that are left are the reset function and the step function. So what are we supposed to do with them? Let's start with the reset function, which is easier. As I mentioned, the reset function is used to initialize your object variables to to their initialized state. What is the initialized state of these variables? They are they are the values that we can see in the constructor. So these things always stay the same. And if you scroll all the way to the bottom, this action space and observation space, do not touch them. You just put them in the constructor and you don't look again. So the values that changes as you play the game are these in the middle. Snake position, snake body, foot position, if the foot is there or not, the snake direction, the change to and the direction variables, the score, and the game over variable. So for that, let's take this and let's put that in the reset function, as we can see here. And we are obtaining the observation. And as I mentioned, we are observing the snake position and the foot position. So let's do that. Self.snake position of 0, self.snake position of 1, self.foot position of 0, and self.foot position of 1 of the y, which is the second element of the array. And here there's something that's very important that I want to highlight. First, let's fix the indentation. And this is something that I've read from many places, which is to make sure that this is a numpy array. So for that, I will make this a numpy array. And we want to make sure that the D type of that NumPy array is the same D type that we've used in here at the top. Now the stuff that we were observing are numeric, they are numbers, but just make sure that it's the same thing in here, and let's put that in there. And yeah, I think this should be good. Let's look. Okay, I don't think it matters, but let me just this. Okay, so far we are doing very good. So now we are done with the reset function. So what about the step function? We are returning four things, right? The observation, the reward, the done, and the info. Let's start with observation. We mentioned it's the same thing, so let's copy and paste. So what about the reward? I will keep the reward in the end because it's the most important thing, which is the one that I want you to pay attention to. The done function is when the game is done. So let's ask ourselves, when the game is done, the game is done when the game is over, or in another word, when the game over Boolean variable is set to true. What about the info? It's something extra that you can add to your step function. In our case, it's going to be an empty object. So now the last but not least, the reward. I usually prefer to just initialize it as 0, which is neutral, not bad, not good. And let's try to think for a second on how we can reward or punish our AI. So when we think of this simply, when we can say that our snake did a good job, and when we can say that our snake did a bad job. Well, the snake did a bad job if it lost the game, or in another word, the snake did a bad job if the game was over, right? So let's start by implementing this. So if self.gameOver, that means that we want to make this bad, so we assign it a negative value. So when it did a good job, it did a good job if it ate a certain food because of that action, right? So when does it eat a food? It's when the score is appended. And if you looked at the top, here you can see the score is appended, or in a different word, if the food position and the snake position is exactly the same. So let's copy that and let's put that in, and let's assign that to 1. Now, what do you think will happen if we train the model like that? Do you think that our AI is going to be trained very well? The answer is no. How do I know that the answer is no? First, because I tried that because before the video, and there's something that I want you to take from this hour. If you forgot everything here, just remember this: experimentation. Always experiment different things as you train your AI, and you'll discover more and more amazing things. And one of the most important aspects of what you should experiment on is the reward and how you are rewarding your system and trying to see its behavior based on the different reward values. So there is one problem with this system. And the main problem is if you run this AI for like 1,000 times or 2,000 times, it will render useless. Why? Because the chance of the snake eating the food in these conditions are extremely slim. And I would say with confidence that over 90% it's going to lose the game because it doesn't understand how it should reach that food. And for that, we need to teach our AI how to get to that food, or we need to motivate the AI to reach that food. So in order to achieve that, we need to look at the position of the food and the position of the snake. So if after you run a specific action or a specific step and you notice that the snake is closer to the food, it means that the snake is doing the right thing. But if you notice that the snake is going away from the food, it means that your AI is probably making a wrong decision. So for that, what we are going to do is comparing the current position of the snake with the previous position of the snake and compare the distance between the snake position and the food position in comparison to the previous snake position with the food position. And since we are concerned about the distance, we're actually going to use we are going to take the absolute value of the difference between the position of the snake and the position of the food. Let's see how that looks in action. So, else if. Now, since we want to compare with the previous position, before I write this, I will create a new variable called the previous snake position. Let me put it here. And I will assign it, initially it's the same value as the current snake position. And something very important before we even continue. We need to make sure that the snake, that anything that we put in the constructor, we need to make sure that it's in the reset function. Extremely important. Otherwise, when the game is done and the AI will try to train again, it will think that the previous snake position is somewhere far away from the current snake position, and it will be extremely confused. You do not want that. You don't want that. Okay? So I put this in the reset function. So let's scroll to the step function and add our logic to compare the distances. So else if the absolute value between the difference between the current position for the snake in X and the food position in X plus the difference for the current snake position and the food position but in the y-axis, if that is larger than, and let me copy the same thing, and let's say this is the previous snake position. So what does this mean? That means is if the current position distance is larger than the distance of the previous position, it means we are going farther and farther away from the food, which is a bad thing. Therefore, we want to punish our AI by assigning a negative value to our reward system. So let's assign this to -1. Else if, instead of writing everything from scratch, let's do it like that. We want to reward the system if the current position is closer than the previous position, as you can see here. And something that is of utmost importance. We want to make sure that after we do that, that we want to assign the previous position with the current position, because the current position will be the previous position of the next iteration or the next step. So let's do that. Now there is one tiny problem if we did it like that. And the problem is, here the snake position is being passed by reference to the previous snake position. So if you change the snake position in the next iteration, the previous snake position is going to is going to change as well. And we do not want that. Therefore, we are going to use the copy function of Python to make sure that the previous snake position is being assigned to a copy of the current snake position, so that if the current snake position changed in the next iteration, the previous snake position stays the same. Okay, now let's go ahead and look back at this reward system. This reward system is definitely better than the previous one. There is just one tiny thing about this, which is that we are saying, or we are claiming, that getting closer to the food is as important as eating the food itself. And going further away from the food is as worse as losing the game. But this is not the truth. These are just motivations to make the AI do the right thing. But the truth is, eating the food and losing the game, first of all, eating the food is way more important than getting closer to the food itself. And losing the game is way worse than going away from the food. Therefore, the magnitude of losing the game or eating the food should be way higher. So for that, I will put some arbitrary value of 100. Okay, so now we did this. Are we good? We are getting better. The truth is, there is even something even better than this. Why? And how did I know? How did I know? Is because I was experimenting before the video, as I explained. And then, um, this is something that you will not think much about when you play the snake game. But then now, if I told you about it, you will be like, oh, it actually makes a lot of sense to the AI. You know what is going to happen if you try to train this? In many occasions, you will see that the snake is going to keep rotating around itself forever. And now you might be wondering why it's doing that. Because it's trying to fear the chance of losing the game. Because it's looking at this reward, it's looking at it, it looks that it's minus 100, and it's like, oh, that's extremely bad. Let's avoid it at all cost. Let me show you what I mean by this. I will just run the snake game again. So this is what I mean. You'll see the snake game just keep rotating like this forever. Which makes sense from AI perspective because it thinks it's doing fine because it's not losing the game. However, I want to avoid that in our video. So I'm going to do two things. First, I will ignore this logic. You'll tell me, okay, but that will make the snake more likely to lose the game. I will tell you, yes, that's true. However, if the snake was trained properly, it will actually try to go to the food. So, and since it will try to go to the food, it's inadvertently not hitting the walls. Now, of course, going back to this logic, the chance of not hitting the wall is is more rare than this, but in return, this will give me a higher chance of getting higher score. But it's true that the chance of hitting the wall using this logic is higher, but at the same time, the chance of getting a higher score, believe it or not, is much better with this logic. And for that same reason, since I don't want for the game to keep stalling because of that chance of the snake keep rotating forever, I will create a new variable and I will call it counter, and I will give a time limit before the snake hit the eat the food. So for each score, or like for if for 100 step the snake did not eat the food, the snake loses. This is an additional rule I just created so that we can see how the game looks like in action, or how to see how the game looks better in action. And of course, I recommend that you take this file, the final file, and try to change some stuff and try to explore. It's extremely fun. Okay, so now if you put something in here, very important, you put it in the reset function. And I will go to the step function and I will increment that by 1. And I will say if self.counter is longer than 100, so is if for 100 steps you do not eat the food, you lose immediately. So for that, I will just return the step function. I will copy this code and then I will modify it slightly. The info is an empty object. The done is true. Now, in reality, in the original game, it's not, but in my modification, it's going to be true so that we don't see the snake keep rotating. And I will assign this to -100. I will tell it, whatever happens, do not keep rotating around yourself. But you'll tell me that way it will try so hard not to rotate around itself, which is true, which is true. So anything that you do in your reward system has good advantages and it has advantages and disadvantages, and you need to balance your thoughts and how you are going to do it. I'm doing this based on my experience, but again, you probably can achieve better results. You might achieve worse results. This is the fun of training the AI. Okay, I love to put things in the same line, and yeah. And one very important thing, which is that if the snake ate the food, I want to reset the counter. So I will take this and I will put it there. And there is now one more thing before we finish writing the gem environment that I want you to pay attention to. Since I didn't care about losing the game, then there is a high chance that the snake will eat itself, right? Because I did not tell the snake um, that it's bad to eat itself, which makes actually sense, and this is something that you will see. However, this is something that I recommend you to do, which is how can you implement a logic to prevent the snake from touching itself? And if you did, would that make your training better or worse? So that will be your assignment. Okay, and I think everything looks good now. Um, okay, so now we are done with creating our environment. With that being said, let's scroll down to the bottom. Now, since we created our environment, what should we do here at the bottom? Very simple. We assign the environment, we create a new environment object, just like we do in any Python program. And at line 174, where we are assigning the model to the right reinforcement algorithm. Now, based on my experience with this game, I have tried to use many algorithms, and the one that worked best for me is the PPO. So this is based on experimentation, not based on not based on knowledge. Now, that being said, there are some algorithms that only work with discrete actions. Some of them only work with continuous actions, etc. Okay, and that's it. Now, before we test it, I will just run the program only once with one iteration. I just want to make sure that there are no syntax mistakes, there are no issues within the code, and then I will train the model and we will be able to see the finalized result. Okay, okay, this is the snake game, my bad. I meant to run the main game, I mean the our AI. Okay, so there are no exceptions, so that's a good thing. Now I'm going to train our AI to run 100,000 iterations. You'll tell me why 100,000. I noticed that after 100,000, it performs generally well. at least for the video perspective. Now, of course, it will take some minutes, maybe 3 to 4 minutes. I will add timestamps if you don't want to wait that long. And the second thing is, in order to avoid, like, let's say that you don't want to keep teaching the program every time. You don't want to waste minutes every time running this. You want to save the model, and for that, I'm going to actually save the model, and I will save it. I will save it under a file called Snake AI model for now. And this will create a zip file that has our model, and then we can actually load the model without training it every time. And let me put like 1,000 iterations, and yeah, let's run this and see how it will go. Fingers crossed. And something that of course you can skip the video. In the meanwhile, for people who want to stay, I will tell you some funny stories while making this video. This is, I think, my third or fourth attempt to make this video, and I spent hours and hours. Every time I make some small mistake that ruins this experimentation entirely. Um, or sometimes I do something, then I discover, oh, maybe there was a better way to do it, and I kept doing this over and over again until I found the final result that hopefully you will be about to see. So if you hear me saying this, it means things are probably going to be good. Especially like one of the main mistakes that I made are for the reward system, which I wanted to explain highly in the video. Um, yeah, just and also the algorithm. Like I always use the A to C, the active critic, because I don't know, that was in the main example. But then I thought to myself, maybe I can use different algorithms. And surprisingly, there was some good difference between the PPO and the A to C. So yeah, just pay attention. Also, if you made a mistake in just one variable, in one line, your logic is going to go all the way to the bottom, and your model is not going to work properly. So make sure that you pay a lot of attention to what you are writing. Um, yeah, so I just want to share this with you. But this is the third time I record this video. The first time took me 1.5 hours. The second video, the same thing. Um, Hopefully this one will not take that long, assuming that this will work from the first time. Okay? And I think I know we are in halfway through because if you look at the console on the bottom left, you see the number of updates to 300 right now. And it keeps incrementing to 10. And if I'm not mistaken, once it reaches 500, we will see the snake game in action. Now, I will not spoil you the performance of the snake, but again, the purpose of this video is not like to provide the perfect model. It's more really about learning how to implement reinforcement learning and then learn from our mistakes and then show you to how to create a custom environment. This is something that I didn't see much in videos. Like every time you see something about reinforcement learning, you see that cartpole example, or you see some of the pre-built examples, but you don't see much about custom environments. So this is where it hits me that I wanted to do something with a custom environment, which is what you probably would want to use if you want to use reinforcement learning. Okay, so we are about to be done. Please work. Please work. Ah. Okay, please do well. My AI, please go ahead. Okay, so let's see. So it's doing not so bad. As you can see, it doesn't care much about hitting the wall because I removed the game over from the rewards. But overall, it's going to the food fairly well, if you want my opinion. And as you can see, this is just from training the model for like 5 minutes. But imagine if you train this way more and how accurate it is. And this game, by the way, is extremely difficult. Even after I made the window size smaller. Now, why is this difficult? Because you want to take into considerations that the there are a lot of pixels in this. Actually, let me run this again in 2000 range, and so that we have fun. I hope that you are enjoying this as much as I do. Okay, I wanted to stop this because I already saved the model, so we don't have to iterate 100,000 times. So what I'm going to do, I will skip all of this and I will load the model immediately. So for that, I will use the PPO function and I will paste the file name, which is this one, and let's run this. Yeah, so sometimes it doesn't eat the food, but even if when it doesn't eat the food, you will notice that it's very close to the food in many of these occasions, like this one and this one as well. Um, Now, if you added a negative reward for the game over thing so that it doesn't hit the wall, instead of going to the wall directly like it's doing right now, it will keep rotating around itself. But I did not want to do that or to show that in the video so that we can see better how the AI behaves instead of just keep resetting the game. I hope that gave you a very good idea on how to use reinforcement learning of this game. And this game, I don't need to mention this again, is even though it's actually way harder than the cartpole example, because in the cartpole you only have two inputs, and the logic isn't really that complicated, and the windows like the observation is not that large, right? But here um, there's a lot of positions for the snake, etc. Yeah, but overall, I think it's doing a good job for such complexity and for a higher number of inputs. And that's it. I hope that you really enjoyed the video. I will go ahead and push it to the GitHub repository right now and see you next week. Thank you and goodbye.